and creating topsoil and all the plants. There is no equivalent of that in the solar system. But Fab Lab 2.0 is the beginnings of the ecosystem that we're going to put in the solar system, which will transform it the same way that life transformed the Earth. And then we can exist at the top of that food chain in a much larger world than we have today. We just recently found out that the moon has ice. It has carbon, nitrogen, and oxygen and hydrogen in the ice, so we now know that there is nothing that can't be made on the moon. And that's great, because that's the leaping off place to the rest of the solar system. People might think, well, doing things economically in space is crazy because of the vast distances and the expense. But if you talk to our forebears about the idea of crossing the oceans economically, they would have thought that was crazy too. It was a heroic, epic journey. But now we cross the ocean routinely with consumer goods that are sold for an hour's wage. This clicker probably includes about 6 ocean crossings for all the different materials and parts, and then it's sold for $15. You know, it's crazy. So we can do that again with space. Now in the 70s, people were talking about manufacturing with 10,000 people in space, living in these vast facilities, but it was too expensive, it could never happen. We realized we need robotics, self-replicating lunar factories is the way to go. There was a study done in 1980 which defined one of these factories. It was 100 tons of hardware in this lunar fab lab. And they recommended that, because at the time we couldn't do it, they said, we need to develop that kind of robotics to where we can do this. Well, we're now living in a city where this is being done. And all the technologies you need for that lunar factory exist. So there's no reason to put it off anymore. So we're recommending a bootstrapping approach to make it affordable. We don't want to launch 100 tons of hardware to the moon and then find out if it works. So instead, we would send a Generation 1 lunar fab lab, which is kind of simple. It'll take materials from the moon and begin making things, but it can't make everything. Computer chips and many other things. So we send additional hardware, the robots put it all together, and now you've got Generation Lunar Fab Lab, Generation 2 Lunar Fab Lab, which is expanded, and it can build more of the things. And we begin making more things with lunar resources, launch some more. You notice the arrows are getting thinner coming from Earth because we send less and less. We make Fab Lab number 3, and we continue this process until eventually we don't have to send anything from the Earth anymore. We have a complete lunar supply chain. And once we've got that, then we can scale it up, grow it exponentially, and build anything, and transform life on Earth as well as life elsewhere in the solar system. We could do things like space-based solar power stations, beaming abundant, scalable, clean energy down to the Earth. We could put all the computing off the Earth to unburden the Earth of that power load. We could have planetary defense to deflect asteroids, make it a safer place, transportation hubs and spacecraft. We could do vastly bigger science than the Type 1 civilization could ever afford to do. Bigger particle colliders, giant telescopes that would allow us to see an automobile on a planet around another star. That's really possible if we could build big enough telescopes. And so what would this Fab Lab include? Mining, chemical processing to extract the elements from the mined material, mining the ice on the moon and distilling it, additional material processing. Then we've got the manufacturing and construction facilities. We're going to make solar cells, fab hardware, because this is 2.0, making assembly robots. The solar cells power the whole thing, and by our best estimates, you can do this process to make solar cells using less energy than those solar cells will make. So it has a positive metabolism. This is a viable form of artificial life we can put in the solar system. And then when it scales up, it's going to make benefits for humanity. And even along the way of scaling, of bootstrapping it, even before you get a full system, it's making rocket fuel and provisioning human outposts on the moon. And since we're doing space exploration anyways, and because this whole thing costs a small fraction of the currently existing national space budgets in the world, therefore it actually pays for itself. We've done modeling of this. We've looked at a first generation lunar fab lab. less than 10 tons of equipment. It can produce about 1 kilogram per hour. The modeling shows that over 6 or 7 generations of hardware, over several decades, you could have 40,000 tons of hardware on the moon, and we've only launched about 100 tons. We've built a number of pieces of equipment in the space programs at NASA, Canadian Space Agency, European Space Agency, and others have been building equipment and testing, mining, extracting resources using solar concentrators to melt the regolith. We've tested and reduced gravity equipment, and we've done 3D printing with regolith on robot arms. That's a little cone we've made of printed regolith. And but the one thing I want to end with is the mining equipment. We've done a different approach for developing mining equipment. We have crowdsourced it. Every year we have a student robotics competition where we get 50 teams bringing robots to the Kennedy Space Center. And I've been one of the judges, and I'm there taking notes on all the robots and watching them perform. And we've learned so much because we could only afford with our budget to build 1 robot per year, but then we get 50 per year for free. And with all these creative minds testing new ideas. So we've really moved this state-of-the-art down the road through crowdsourcing. So I would suggest that the Maker movement could do the same thing for all the other pieces of the Lunar Fab Lab, and that we could seriously contribute to getting humanity off the Earth. To end, we're near the limits of the planetary civilization, but Fab Lab 2.0 can take us beyond the planetary limit to a solar system civilization and beyond.